All right. All right, so we've got chapter 1-6 and scatter plots. A lot of this overlaps, which is why I was going to try to combine 1-5 and 1-6, but the notes went a little long, so I just decided to keep it separate. All right, so we are going to be talking about positive, negative, or no correlation. And above the word correlation, I want you to write the word relation because they are interchangeable. Oops, let's not do it in purple. Okay, relation and correlation are interchangeable, and you're going to see it both ways. If it asks you to state the correlation, it's negative, positive, or if it asks you to state if the relation is negative or positive, those two words are interchangeable, okay? So this first example here is positive correlation, okay? What makes it positive correlation is that all of the points, so when you guys did on your homework yesterday, you graphed those points on the graph. That is a scatter plot, and it's basically just putting data on a coordinate plane, okay? So you gather data and then you put it in the form of X and Y coordinates, and then you graph them, and all of the points on the graph give you a visual of the data. So in this particular case, you'll notice that all the data points and all of these are ordered pairs, and all of them are kind of trending together in a, not really an exact straight line, but they're trending upward together in what we could call a straight line. And so what we try to do, and when you do this on paper, you'll take a ruler or something, but you just kind of take a ruler or some straight edge and you set it down to where it runs just kind of through the middle of your points like this, okay? And this is called a trend line. We add a trend line to our data, and we'll kind of go into why here in a little bit, and you'll notice, right, the trend line doesn't hit every single point. It just kind of runs through the middle of the points, and you can see that all of the points very softly follow that trend line. And since it's going uphill, we call that positive correlation. Now, there's two ways that you can get positive correlation. So underneath on your notes, under the word positive correlation, I want you to put both variables increasing or both decreasing. Either one of those makes for a positive correlation. So what do I mean by variables? So let's say I did a poll and I said when the weather increases, you buy less or more ice cream, and most people are going to say more ice cream, right? Hot weather, so when the weather goes up or increases, the sales of ice cream increases. So that would be considered positive correlation because when one goes up, the other one goes up, okay? Another example of both decreasing is, let's say you eat less calories, and so your weight goes down. Well, if your calories are decreasing and your weight is decreasing, that's considered positive correlation, and it kind of gets a little trippy because you think everything's decreasing, it should be negative. If they're doing it together, whether it's up or down, if they're doing it together, it's considered positive correlation, okay? Negative correlation is when one variable increases and the other decreases. I'll put the ampersand there. So for negative correlation, and you'll notice our trend line there, we can draw in there. For negative correlation, you've got one going up and one going down. And so an example of that would be as the temperature increases, sales of hot coffee decreases, right? When the temperature goes up, sales of hot coffee goes down. You've got one going up, one going down. Doesn't matter which one's which, because one's going one way and one's going the other. And if it helps you to kind of draw, whoops, let's change that to black. If it helps you underneath both of them to draw the arrows, you either got both going up or both going down. Okay, that's going to give you positive correlation. For negative correlation, you've got one going up and one going down. Okay. The trend line for negative correlation, again, right? You just kind of get your line of best fit to kind of go through most of your data right through the middle of it and form a line that trends downward. And you'll notice again, none of your data points, or not all of your data points, sit right on the line, but they all kind of hug the line all the way down, and they trend in a downhill angle, and that's considered a negative correlation. And then the last one is no correlation, right? The color of your hair and the sport you play has absolutely nothing to do with each other, right? So the data points here, when I start constructing the plot, it's just going to be all over the place, and you can't see a trend. You can't see any kind of relationship between all of those points, and that's considered no correlation. Okay. And again, you can also put relation if you want, because no correlation, no relation, it means the same thing. Those two words are interchangeable. Okay. And I would, if I were you in your notes, I would put the arrows just as a reminder. Positive is both up or both down. And negative is when one goes up and one goes down. Okay. All right. So let's scroll down to our second slide. And I want you to go ahead and put an X through number 2, because this is from a slide. It's like a 7 or 8, 9, 10, whatever slide presentation for algebra. And in pre-algebra, at least now, we're not going to get into nonlinear. So we're not going to talk about that. And these are just examples. So you'll notice on example number 1, you've got all the data points, and I'm going to show you, I'll try to lower it so I can reach it. There we go. So what you're going to do is you're going to graph some data points when you get your homework. So you're going to graph the black data points, and then that red line is not going to be there. You're going to take a ruler or your finger or your pencil or some sort of straight edge, and you're going to you're going to play with it a little bit, right? You're going to kind of set it and kind of adjust it a little bit and get it to where it's running through the middle of your data point. Now, everybody's line may not be exact, because you might put it like this and somebody else might put it like this. It's a slight adjustment, and it's no big deal because they're both in that kind of area of acceptability. What you wouldn't want is this would not be acceptable, because this does not really accurately follow the trend of the data. So you wouldn't want something like this. Obviously, you wouldn't want something like this, right? Or something like this, because you're not anywhere near your data. So when you go to plot your points, and then you go to draw in this line of best fit, you're just going to want to kind of play with your ruler and get it set to where you go through kind of the meat or the heart of all your data points. Okay, sound good? All right. So that's an example of negative correlation, okay, because it's a downhill trend. This is an example of no correlation. There's nowhere that I can put a straight edge and pick up all of my points. I can't see any kind of trend happening there. They're just all over the place. And then this is an example of positive correlation. And again, right, that red line, there's a little bit of personal choice in where you put that red line, but it still has to kind of go. And so somebody else might put it, let's see if I can do a line here. Somebody else might start it down here and run it like this. And you may not think that's a big deal, right? They look almost the same. But if I was to ask you, what's the coordinate that goes with 100? Whoops, go back to pencil. If I was to ask you the coordinate that goes with 100, 100 is the X value, right? If I want to go up and find the Y value, if one of you drew the red line and one of you drew the black line, is your Y value going to be exactly the same? And that's okay. As long as it's in that kind of acceptable area, you're good. All right. What you wouldn't want is a Y value way down here, because that obviously is not trending with the data. Make sense? All right. Let's see what else. I think we have one more slide here. Yeah. So I've kind of already addressed this a little bit, but why do we draw the line of best fit, right? Why do we draw that trend line through our data? Well, we do it to make predictions. So if we use this with this one as an example, first, anytime you see a table, look and see what each axis represents, kind of what story is the table telling. So in this one, we've got the average yearly consumption of bottled water by people in the US starting in 1990. So you've got your years down here, right? And then you've got the gallons of bottled water along this side. So the black dots are the actual data that's been collected. We can draw a line of best fit, which is what this black line is here. This is the line of best fit that is added afterward. And if we extend that line all the way across our graph, we only have data up to 1998. And you notice this is always important in a graph. You've got 90 and 92, which makes this one right here 1991. 92, 94, right? So that makes that one 1993. So sometimes it makes it easier if you'll go in and fill in some of the gaps there. But we only have data to 1998. But with this trend line, we can make a prediction about what would happen in 2000. And the way we do that is we take our pencil and we go up until we intersect our line of best fit. And everybody's intersection might be at a little different spot, and that's okay. And then from there, go over and connect it to the y-axis, and that is your prediction, right? And remember how I told you when you graph points, you should make this box. So you go up from 2000, intersect your line, put a point there, and then follow your eye or your pencil over and see where does your prediction land. Well, again, you got to look at what these numbers mean. You've got 10 and 12, which means that's 11. So that one's 13, that one's 15, 17, 19. So you can predict based on your trend line that in the year 2000, each person will use an average of 19 gallons of bottled water. So that's where your trend line comes in. And you could even go out further if you wanted to. We're not going to, but if you wanted to know 2002, right, you would go out to here because this is 02. You'd follow it up and you'd have to make your line just a little bit longer, and you could follow it up and you could make predictions as long as you've got a graph. Okay, good with that? All right. On this next part, we're just going to talk. You don't have to write these down. We're just going to talk through what some of these might mean. Okay. All right. If I have a person's jogging speed and their time spent jogging, we need to ask ourselves, would they both increase together? Would they decrease together? Or would they go the opposite direction? So if somebody speeds up, how are they going to spend less time or more time jogging to complete, say, the same 5 miles? Blake? Right. If they run faster, then they're going to get done sooner. So their time spent is going to go down. Likewise, right? Because remember I said it doesn't matter which way. What if somebody slows down a lot? Well, then they're going to be running a lot longer. So either way you think of it, slower or faster, their time is going to be inverse, right? Or opposite. So then that one would be what? Negative. Yeah. Okay. So now you've got the size of a family and their weekly grocery bill. So first think about it. If a family gets bigger, right? If a family gets bigger, what's going to happen to their grocery bill? Yeah, they're both grocery bill is going to go up. So that one would be positive. And you could think of it the opposite way too. Like with me as an example, right? My size of my family went down because my daughter got married and my son's getting ready to move out and get his own apartment. So what's going to happen to our grocery bill? It's going to go down. So either way, either they both go down together or they both go up together, but either way, it's positive correlation. All right, this one can be a little tricky, but we'll think through all the different kinds of cars. You've got the size of a car and the cost of that car. So think about that. Do you think there's a correlation? Can you have cheap little cars, cheap big cars, expensive little cars, expensive big cars? What do you think?
I think no correlation.
No correlation. I think that's probably the best because you can think of it at first and you can think, oh, well, trucks and SUVs, they cost a lot of money. So do Maseratis, right? So do Corvettes, and those are teeny tiny little cars. So really the size of the car doesn't really matter the cost. So really here, size and cost, there would be no correlation or no relation, whichever way you want to write it. Good. All right, so now we've got a person's weight and their percentage of body fat. So you can think of it as up or down. It doesn't matter. If you think of a person's weight going up, what's more likely happening with their body fat? Inlo? Yeah, it's going up. And same, right? If their weight's going down, their body fat's probably going down. So what would that be, Inlo? Good. All right. Time spent playing video games and time spent outdoors. What do you guys think? What if you spend a lot of time on video games? What's probably going to happen to your outdoor time? Yes, sir. Yeah, it's going to go down, right? Can't be in both places at once unless you move your Xbox outside, which I could probably see a few people doing that. All right. Would that be negative or positive? Yeah. You got one going up and one going down, or one going down and one going up, but either way, they're going to opposite each other. So that would be negative. Okay. You're going to have one like this on your homework. So if you don't have to sketch this if you don't want to, I think it's a pretty easy concept, but if you want to, you certainly can. So the directions say, draw a scatter plot with 10 ordered pairs, which just means a point, right? 10 ordered pairs that show negative relationship. So all I know is I need 10 dots on this graph, and I need them to show a negative relationship. It doesn't tell me where they have to be. It doesn't give me the ordered pairs. So I can just randomly place 10 ordered pairs or 10 points on this coordinate plane. I can put them anywhere as long as they trend kind of close together, trend downward. So use your own judgment here. You can put them anywhere you want. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll stick one up here, 10. Now, notice you're going to put them somewhere else, right? You're not going to put them in that exact same spot, but that's okay, because what I need to be able to do to show that I did it right is I needed to be able to show that I had a downward trend because I wanted negative, right? And I wanted them all to somewhat hug that trend line. So I wouldn't want to put a point, say, out here. That one would not, that you couldn't make that as one of your 10 because it is nowhere close to the rest of your points. You want them all to kind of be in a close relationship with each other. So don't have any of those crazy ones. All right. I think on your homework, it says 6. So, and yours might be positive. So you're just going to do the exact opposite. You're going to put 6 points relatively close together, trending upward in a linear or a straight line upward. And then on your homework, it says explain. Here's what it means. When anytime your homework says explain, okay, what that means is, because I'm putting this on here because I know your homework does say this. What it means when it says explain is first do it. So that's this, right? We did it. And then kind of put into words what went on in your brain to make you do this. Why did I put these 10 points like I did? Well, because it needed to be negative relationship. Okay, explain why I did it. Well, I put 10 points all close together, right? Trending down. Now yours isn't going to be worded just like this. I'm kind of showing you what I want when it says explain. Put in your brain why you did it. If you had to come up to your grandma and your grandma said, why did you do this graph? What would you say to your grandma? Well, I had to do a negative correlation, so I needed them running downhill and I needed them to be all close together, kind of close to one line. I'm good with that. So act like you're explaining it to your next door neighbor, your dog, your grandma, whoever asks you. Please don't tell me your dog asked you. Whoever asks you, why did you do this? How would you tell them in words how you did it? That's all it means, explain. I don't need you to get fancy. You don't have to use big math terms. Just act like you're talking to your best friend. Okay, we're good there. All right, and then last is you have to be able to plot some points and then draw a line of best fit. I'm not going to plot all of these for time's sake. So when you get your table, you'll plot them all. You won't have this many anyway. So I'm just going to skip around a little bit and plot a few of them. So I've got 1950, minimum wage is 75 cents. Notice you've got your years along here. You've got your money here in dollars, okay? So kind of get to know your graph. So I'm going to plot, remember this is an ordered pair, an X and a Y. So I'm going to go to 1950, which is right here, and I'm going to go up to 75 cents, which is just under $1, okay? Now I'm going to skip around a little bit. Now I'm going to go to 1965. Notice I've got 60, 70, so this one right here is 65. I'm going to go to 65, and in 65, it was $1.25. So just over $1, not quite to $1.50. Okay. And if you look, If this is 1 and this is 2, then right here would be about 1.5. So you're going to have just under 1.5. And then I'll skip down here. We'll go 1985, which is right here between 80 and 90. And in 85, it was 335. So I'm going to go up to 3 and then just a little bit up over 3 because I want 335. Notice I can't be exact. Best you can. It's just a little over 3. And then we'll graph 2000 at 515. So in the year 2000, we go up to 515. Now, of course, you're going to have more points on yours, just a hair over 5, because you would graph them all. But for time's sake, I just want to graph some of them. So when you're graphing, this is your X, right? This is your X. This is your Y. You go over as far as you need to line up with your X, and then you go up as high as you need to line up with your Y. And if I was to draw a line, what I should have is a box created by 85 and 315, right? 85 and 315 or 335, which was this one. Okay. So anytime you don't put those dotted lines on your graph, but visually you should be able to do that box to make a box with your X and your Y. Okay. Now it asks a couple things. Does there appear to be a relationship between the year and the minimum wage? What do you guys think? Does there appear to be a relationship? Do they trend in the same direction? Can I draw a line that kind of whoa, let's not do that. Can I draw a line that, seriously, there we go. I can draw a line of best fit that trends with my data, right? So yes, there's a relationship. Anytime you describe a relationship, is it positive or negative? It's going uphill. My years get bigger, my minimum wage gets bigger. So it's what? Positive, because they both increase. And then it says, based on the graph, predict the minimum wage in 2010. Well, here's 2010 right here. Here's 2010 right here. So to predict, again, I'm going to go up, I'm going to intersect my line, and then I'm going to go over and predict that in 2010, it's going to be $6 an hour. Are we good? All right, you've got the worksheet on the back of 1.6 or on the back of 1.5, so it's 1.6. Go ahead and do them all because really the top 3 go together and the bottom 3 or 4 go together as one problem. So for numbers 5, 6, 7, and 8, 5 is you're going to plot the points, and then 6, 7, and 8, you're just answering questions about that graph. Okay. For those of you at home, go ahead and scroll down to the bottom of the assignment, hit load in Cami, and use your pen tool or your text box to answer each one of the questions, and then submit and submit. Email me if you have any questions.